All right, let's look at this. Okay, so to solve a logarithm, we're going to use the basic property that logarithms and exponentials are inverses. I'm going to isolate the e to a power. I'm going to isolate the e to the power, and I have e to the power isolated. So I'm going to do ln of both sides. Now you have to remember that ln's and e to a power are like squares and square roots. They're opposites. So over here, this ln of e to the power cancels, and you have x plus 1. And over here, you have the ln of 7. And what would you do to both sides to solve that equation? X equals ln 7 minus 1. Well, gosh dog it. There it is. Couldn't find that. Okay. All right, so now to solve an ln, we're going to isolate the ln. And again, the ln is isolated. And what's the inverse of an ln? A base of e. A base of e. And what happens with the e and the ln? They cancel. E to the 5 is some number. 40-something probably, I don't know, maybe 50-something. To solve that equation, I'm going to add 3 to both sides and divide by 2. Okay? Any problems? All right. So now I want to take the derivative of e to the u. The e to the u, the derivative of e to the u is the simplest one. It's the easy one. The derivative of e to the u, and I think you memorized this when you took Cal 1 from me, is e to the u times du. So the derivative of e to this is e to this times the derivative of that. And the derivative of that would be 2. Fine answer, your teacher will probably write it like this, probably put the coefficient in front, but it's the same answer. The derivative of e to the u is e to the u. So the derivative of e to the negative 3 over x is e to the negative 3 over x times the derivative of negative 3 over x. And if you write that as negative 3x to the negative 1, you'll see that your derivative is positive 3x to the negative 2. And again, that's a fine answer. Your teacher might write it like this. Got a question on something I did up there? All right. All right. You'll ask me if you get one, though, right?
Yes, sir.
All right. Find the relative extrema. That's the hills and the valleys. And we're going to find the x number and then plug the x number in to find the y number. And the hills and valleys, you probably learned this in, I know you learned this in Cal 1, is where the derivative equals 0. Now, that's not just e to the x. If that were plus, life would be easy, but it's not plus, it's times. So we're going to say x times the derivative of the second plus the derivative of the first and leave the second alone. Remember the product rule?
Yes, sir.
That's what we're doing here, product rule. And I don't know if I did this when I taught you. I now require you to factor out that common exponential factor. And so the only way this is my derivative, and the only way my derivative could equal 0 is if this equals 0 or if that equals 0. Of course, this is 2 to some power, so it will never equal 0. The only way the product could equal 0 is if this thing equals 0, which means x would have to be negative 1. So my relative extrema is at the point where x equals -1. And if you plug a -1 into this, you get -1 e to the -1 power. So you could write the whole thing as -1, comma, -1 over e. So the location of the relative extrema is at x equals -1, and the value is -1 over e. We haven't yet determined if that's a max or a min, and they didn't ask that, so I'm not going to worry about it. Okay, solve the equations. Now, what do we know about e to a base and an ln? How do you solve an equation for e to a base? First of all, you have to get e to the base by itself. So I'm going to subtract 9 from both sides. I'm going to divide by -2. And this one's kind of easy. What does the exponent have to be so that e to the power equals 1? What variable, what exponent gives you 1? 0. X equals 0. You could do ln of both sides, but the ln of 1 is 0. Again, how do you solve an equation for e to a power? You isolate e to the power. I'm going to divide both sides by 50, and I'm going to reduce it if that's okay with you. I'm going to take an ln of both sides and get -x equals the ln of 3/5. And all of that gives me x equals either -ln of 3/5 or the ln of 5/3. And I went really fast there, but remember that you can take a coefficient and turn it into an exponent. So that -1 could flip it for me. Either one of those answers is fine. That's probably the way your book's going to have it. All right, how do you undo an ln? Base of e, with the base of e. And that gives you x equals e squared, 2.71828. All right, let's do some derivatives. The derivative of e to a power is simply e to the power times the derivative of that power. This one is a product rule. This one is a product rule. So I think the way most schools teach it is leave the first alone, take the derivative of the second, plus leave the second alone, take the derivative of the first. Of course, the derivative of e to the x is the easy one. It's e to the x, and the chain rule says times 1. Any questions on that? Now, what I require is to factor out that e to the x. 1 over x plus ln x. I don't know that other teachers do that. That's just when I have a common factor, I like you to require it out, a common exponential factor. All right, what's the derivative of e to the u? E to the u times the derivative of u. And the derivative of that u is 1. Of course, you could use your laws of exponents and say that's e to the 4th times e to the x, and e to the 4th is just a constant, so the derivative is e to the 4th times e to the x. Or e to the -4th, sorry. And if you add your exponents back together, you get the same thing up here. You could do it either way. You could use your laws of exponents or use your chain rule. All right, so I've got a function to the third power. My derivative is going to be 3 times that function to the second power. And the chain rule is going to say times the derivative of that function, which is e to the -t times -1. plus e to the t times positive 1. Is that clear that that's a negative 1 right there? Is that clear that's a... It's not real clear to me, so I'm going to do it like that. And I could try the quotient rule, but when I do the derivative of the top part, that's going to be 0. So I'm just going to rewrite this as Is that okay if I do that? Just rewrite that as that? Because my top, do y'all do low D high? Is that the way he calls it, low D high? Okay, you do the D high, it's going to be 0. So I'm just going to multiply that in front. Subtract 1, and then the chain rule is going to say e to the x times 1 plus e to the negative x times negative 1. Run out of room over there. It's the same thing I had over here, kind of. You okay? You ready? All right. All right, low D high. I'll go ahead and do it. The derivative of the top is e to the x. The derivative of the bottom is e to the x. So low D high minus high D low all over low low and I think when I clean all that up, that's e to the 2x minus e to the x minus e to the 2x I'm going to do minus that. That's going to be minus e to the x. So my numerator cleans up to be negative 2 e to the x over e to the x. Oops. Whoops. Where's my eraser on this thing? Is that my eraser? Yeah. Minus 1 squared. I'm going to stop that for a second. All right, let's go to the next one. And that's it. That's the end of that one. Hot dog. Oops. Forgot that one. Okay, let's do that. Okay, so I'm going to treat this as a product rule. That times that, and I'm going to take the first times the derivative of the second plus the second times the derivative of the first. And I think you'll see if you look at this that e to the x sine x and e to the x sine x are going to cancel out because one's positive and one's negative. So what I'm going to have is 2 e to the x cosine x. 2 e to the x cosine x.